I have a couple more things to tell you about confidence intervals. One is a bonus and the other is a warning. First, the bonus. Confidence intervals can be used to do tests of significance. Suppose you want to test the null hypothesis that p is equal to p naught versus the alternative that p is not equal to p naught with a level of significance equal to alpha. Okay, this is a two-sided alternative, and you can use a confidence interval directly to make a decision in this case. Okay, first construct the confidence interval for p with confidence level equal to 1 minus alpha. So if you want to use a significance level of 0.05 or 5%, your confidence level will be 95%. And if you want alpha to be 1%, then your confidence level would have to be 99%. Now, in a lot of situations, you might already have a confidence interval that's been calculated, and it would just be a little bit of extra work to do this test and make your decision. Okay? Well, here's how you make the decision. Reject the null hypothesis if the null hypothesis value p naught is not in the interval. That's all you have to do. It's very easy. And if you already have the interval made, then this could save you a lot of time. It's a little extra bonus that the confidence interval gives you. Now, this method can be adapted to one-sided alternatives as well. If you have a one-sided alternative, you have to tweak the confidence level a little bit, and you have to be careful that your sample proportion is on the proper side of the null hypothesis value. Okay, for the interval, you need to use a confidence level equal to 1 minus 2 times alpha. So if alpha is 5%, 2 times that would be 10%, you'd want your confidence level to be 90%. And if alpha is 0.01, you'd want to use a 98% confidence interval. Now you're going to reject the null hypothesis if, again, p naught is not in the interval and this second condition is met. Okay, you need to have p hat greater than p naught. If you have a one-sided alternative, p is greater than p naught. Okay, you've got to make sure that p hat, in fact, the whole interval is on the proper side of p naught. Okay, that means p naught will be completely below the interval in that case. Or alternatively, p hat is less than p naught for the alternative hypothesis p is less than p naught, in which case the whole confidence interval would be below p naught, and p naught would be out of it, and if that's the case, you would reject the null hypothesis. So it's a very nice little bonus. Confidence intervals can be used for tests of significance with just a little bit of adaptation and a little bit of extra work. So if you already have the interval, this is not going to cost you very much, and you get all this extra information. Next, a warning. Okay, you always have to pay attention to the design under which the data were gathered. There is no inference procedure that can overcome a biased or improperly randomized design. So always make sure that your data come from a properly randomized sample or random assignment to treatment groups in an experiment, and you have no issues with undercoverage or other kinds of bias in your sample design and or your experimental design, because nothing can help you if that's the case. Now, confidence intervals will always have margins of error, but that margin of error only accounts for sampling variability. When you take different samples, you get different values for your statistics, and that margin of error accounts for that, but in no way accounts for or compensates for any bias or any improperly randomized design. So always be careful about where your data come from.